Is El Nino coupled with the atmosphere? Is there surf on the way? And could there be more coming beyond? All these questions and more will be answered over the next hour. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, June 25th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like this video, give us a thumbs up, be sure and subscribe. Ring the bell, you'll get automatic notifications when the videos are posted, typically on Sunday evenings. And if you'd like to make a small contribution, use the special thanks button down below, the heart with a $sign in it. Give us a tip, we'd appreciate it. And with that, I'd like to thank the folks that donated from last week. Fish and M, thank you very much. Elliot Harris, Sporman Jason, always great to see you there. Imanatov, Big B, Ben, thank you, glad, and we were working, Ben, thanks for helping so much, try to figure out this issue. When you make comments and you post links in them, some people, the links are getting deleted. I think I modified the settings on the channel so you can include a link, but check it. It might get deleted. This is a YouTube thing, and we don't really have any control on it, over it, but we're trying. Anyway, with that, let's get to work. We'll start by looking at significant wave heights for the South Pacific Ocean, and lo and behold, a tiny little gale is in the Southern California and California swell window with 31-foot seas aimed pretty well off to the north. And this is the beginning of maybe a cycle of two of these getting ready to happen. We'll get into those details in a minute. But there is some hope. So that answers the immediate question. Yes, there is some swell being generated for the future. Quick look at current conditions, that is surf heights along the U.S. West Coast and the Hawaiian Islands. We'll start in Northern California, the Point Reyes buoy, number 029. We're looking at all the energy that's hitting that buoy, anywhere from up to 33.3 second period, really long period energy, which you don't see anything. We see a little bump of something here in about the 13 to 14 second period range, and then a continued little bumps of wind swell. This is down at 5 seconds, so that's basically wind chop, not even rideable surf. So you just see sort of a smattering of a little bit of energy there. Put it all together, primary swell 1.3 feet at 12.4 seconds from 244 degrees. That's like 1.6 foot, maybe knee high, thigh high if you're lucky at top spots. And then some secondary swell. This isn't really a swell, it's just background energy, 0.8 of a foot at 15.4 seconds from 187 degrees, and that's like 1 foot. So really nothing to speak of. We're not even going to look at Santa Cruz because it's pretty much the same situation. So we're just going right down into Southern California, San Diego, Point Loma South buoy, number 191. Same deal, little tiny bits of energy. This 18-second period thing, maybe that's something to keep an eye on, and we'll get into that more in a minute, and then basically just wind swell. Put it all together, primary swell, 3 feet at 6.4 seconds from the west. That's, again, surf 1.9 feet. We'll give it knee to thigh high, and then some background energy mixed in there from the south at 0.8 feet at 13.4 seconds from 182 degrees, and that's 1 foot, so we'll say knee high. So really nothing to speak of. Looking at the north shore of Oahu, this is actually Kauai, the Waimea Bay buoy's down, but you get the general idea of what's happening here. Basically no swell, bunch of wind swell coming from the east. We can look at that here. 5.3 feet at 8.3 seconds from 78 degrees. That's wind swell on the east shore, 4.4 feet. We'll call it chest to shoulder high, something like that. And then finally, the highlight of the Pacific, Barbers Point buoy, south shore of Oahu, buoy number 238. Now, this doesn't look particularly huge, but compared to anywhere else, it's stellar. We see a bump of energy at about 20 seconds. That's a new swell starting to fill in. We have another bump of energy here in the 15 to 14 second period. This is swell that really peaked out on Saturday evening, and then some little wind swell mixed in. Primary swell, 2.6 feet at 13.7 seconds from 176 degrees. That's 3.6 foot Hawaiian. There's definitely waves in the head-high range at best spots on the south-facing shores. And then that new, it's a secondary pulse from the same swell. We'll get into the details in a second. 1.3 feet at 18.3 seconds from 176 degrees. That's 2.5 foot Hawaiian, so again, maybe chest high. So there is surf finally hitting the south shore of Oahu. Everyone there must be very happy. And we're going to go back in time real quick here. We're going back in time. Watch the approach of this swell on the south shore of Oahu. You can see we're here into early on Saturday. You can see the swell slowly building on the energy spectrum here. We're going to try to catch this right at its peak. You can see it definitely jumped up as it went through the day. And we should, there we go, right there was it. 3.9 feet at 16.2 seconds. Theoretically, that's 6.3 foot Hawaiian. I mean, you could double that, 12 foot. It was not 12 foot, but it was definitely a couple of feet overhead. And this was at about noontime Hawaii on the south shore. So this is from the first pulse of a storm that had developed pretty much due south of Hawaii, aimed well at Hawaii. There's a second pulse. We see the swell from that's already starting to hit the buoy. And this energy, or at least portions of it, is heading towards California. So to answer the second question in the intro, yes, there is surf. Clearly it's hitting Hawaii, coming towards California. Now, the other note here is this was way bigger than what the models were suggesting. They were suggesting 2 feet at 16 seconds, and we got nearly 4 feet. Now, look, it was only one reading, but there was a whole bunch of readings here in the afternoon in the 3 to 3+ foot range. So still beating what the model suggested by almost double. So let's go back in time and see what really was creating all this. So this is the southern hemisphere here, Australia, New Zealand, Ross Ice Shelf here, Antarctica encased in ice, and of course Chile, Peru, and Ecuador. Hawaii is at about 158 west, so the equator right here. So it's north, Hawaii is north of there, so up off the chart somewhere here up in this part. Now here's the first part of the storm. This is significant wave heights with seas 30 feet. Did we get a little bit more? There we go. Yes, 31.7 feet, the highest seas over this whole area, with winds in the 43 knot range from the south, aimed due north. So this was a swell that created that pulse at 3.9 feet at 16 seconds. Now, relative to Hawaii, it was a straight shot. The fetch was aimed right at it, and Hawaii considerably closer to this fetch than California, which is sitting over here somewhere with the fetch not aimed directly at it. So don't get too excited here and think there's some mega swell coming to California. That's not happening. But there is rideable surf coming. That's the first pulse of the storm. It faded out. That was on Sunday into Monday the 19th. So that was almost a week ago. Then here's the second pulse of the storm that started developing on late Monday night, the 19th, into early the 20th with 31-foot seas. Do we get another reading? No, 31-foot seas and aimed pretty well to the north, good at Hawaii, also good with California being right about here, so split evenly between the two. We think a good second pulse will happen. We will watch the buoys. You can watch that same Barber's Point buoy on Monday morning and see what materializes from this. Anyway, this system started fading out as we went into Tuesday and Wednesday. Swell from it, 2 pulses for Hawaii, 2 pulses bound for California. And then let's go just through the rest of the week. It was very quiet down south until, let's see if we can get this to pop right here. And yes, on Sunday today, the 25th of June, a new system started developing in the far southeast Pacific. Okay, California is at about 120. The Southern California cutoff is about 117, 118 west, somewhere right here. But we can see another small area, tiny little baby area of 31-foot seas aimed off to the northeast. So that's the end of the Hindcast. Oh, and let's also say, the Hindcast models, they only go back a week. We're in the process of updating those, so they go back at least 2 weeks. So, you know, even as a swell is hitting, you can get a good view of what created any southern hemi swell 2 weeks ago. So that's going to be coming for all the hemispheric models, the North and South Pacific, North and South Atlantic, and the Indian Ocean in the wave model area first, and then we'll probably go do it for the weather models after that. All right, so what's coming beyond for the next week? We're going to start by looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a trough, a push in the jet. So this is the northern branch of the jet. And let's get oriented here. New Zealand, Australia there, Antarctica, and the Ross Ice Shelf down here. The ice line's about 65 south, something like that, right in there. So if the jet is south of 65 south, it's pushing over ice, does absolutely nothing. Anyway, the jet, it's the influential southern branch of the jet stream that really helps support storm formation, and we're looking for troughs, a pushing the jet to the north, just like here. Now this is a weak trough, there's not much wind energy pushing into it. We really want 110 knot wind, something like that. But anyway, when you get a trough, it creates this kind of a flow, a clockwise flow aloft and then also down at the ocean surface, and that is effectively low pressure. And low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface, generate seas. Seas, is those, as they start radiating away from the fetch area, eventually turn into swell, and swell, when it hits your beach, turns into surf. So trough is what we're looking for. And as we get into Monday, here we go. Here comes another trough building clear of the ice line, pushing pretty well to the north with 120 knot winds, and in the California swell window. And then it starts fading out as we get into Tuesday night and Wednesday. Still circulating, probably good enough to generate some low pressure and swell potential for maybe Peru down into Chile. Probably not so much for California. Now, here's the exact opposite. Big ridge pushing south. When you have the jet sort of doing this with a big split in between it, you get high pressure. High pressure does nothing for storm production. But as we get into, where was that? There we go. Let's go back just a couple of days. Right about even there. As we get into Thursday, the 29th of June, notice, so here's Tasmania and New Zealand. Another trough starts developing. This is the Tasman Sea in between New Zealand and Australia. And this is the first one of this entire season. Sort of pushed north, but then it also starts building a trough of some kind just east of New Zealand. And this is what we want to see. The whole focus of storm production has been over here in the far East Pacific since the beginning of the southern hemiseason, and really hasn't changed. The swell that's hitting Hawaii right now is the first gale of any kind to even form west of the Southeast Pacific, so in the central South Pacific. And now, theoretically, maybe just finally, we're not talking till the end of this coming week, maybe something developing under New Zealand. There's your trough, looking pretty solid with decent winds flowing up into it, into Saturday and Sunday, and maybe even into Monday. Now, do I believe the GFS model a week out? Not a chance, but at least there's a glimmer of hope. Now, why is this important? Well, La Nina. During typical La Nina years, the focus of storm development is typically in the Southeast Pacific, like over here, and that is exactly what we've had. I mean, it's just been storm after storm after storm, really focused on Mexico, South America, Central America, and California just barely getting in the action with very south-angled swells. Best south-facing spots in Southern California have done okay. Northern California not as well, and Hawaii's been completely shut out of the picture. Now they're finally getting a little swell, but notice if this happens, just maybe if this happens, typically, during a La Nina, you could get something here, but we're looking for any sign of a developing El Nino. Right now, it's been La Nina, just locked down, and that storm development pattern in the Southeast Pacific is pretty classic La Nina, strong La Nina signal. If something starts actually building east of New Zealand, maybe that would show a little bit of a kink in the armor of La Nina. You know, even though El Nino is building in the atmosphere or building in the Pacific, it's not really doing anything in the atmosphere yet. We're going to get a little bit more into that in a minute, but this is just a teaser kind of. We'll be keeping our eyes on the New Zealand area for signs of swell development. All right, so let's go down to the ocean surface. Surface level pressure, surface level winds. Let's see if we can see the effects of the jet stream on weather patterns down at the ocean surface, because to generate surf, you have to have wind blowing on exposed ice-free waters of the Pacific to generate swell. And of course, not unexpectedly, we have a gale, low pressure here, 45 knot winds. You can see the color right here on the chart, blowing from the south up towards California. This is at 131 west. California is about 122 west, something like that. All right, that's as of Sunday morning, the 25th today. That system starts fading, pushing out of the California swell window as we get into Monday, but another gale theoretically starts building right behind that with 40 knot winds from the southwest, aimed pretty well off to the northeast, and that first gale starts regenerating too, pretty much out of the California swell window, but certainly providing hope for Chile, Peru, up into Central America and Mexico. As we get into late Monday night, we got nearly 50 knot winds down here in ice-free waters aimed off to the north, and then moderating as we get into Tuesday with the whole system itself lifting off to the north. That's what you want. You want fetch aimed in your direction. We'll just play this right back here. You want fetch aimed in your direction, California being up here somewhere, okay? And then the gale itself and the fetch moving with it. I call it virtual fetch. They sometimes call it a captured fetch. Either way, what happens is you generate seas here. If the wind is traveling over those seas as they're trying to escape it to the north, they add yet more energy to those seas, and you start building longer periods and more size. And you can see that's exactly what's happening here. So a pretty good scenario to potentially generate some swell. And then even as we get into Wednesday, the system continues on the hairy edge of the California swell window, then starts petering out. Now, by the time we get into Thursday, the 29th of June, we know there's a trough of some kind trying to organize. We're actually going to go back just a little bit. See the beginnings of the trough manifesting itself in the atmosphere with low pressure just east of New Zealand on Wednesday, the 28th of June. As we get into Thursday, it builds, still not much, 35 knot winds. Now, you see these 40 knot winds here, but they're all aimed to the south, so that does nothing for us. And the low, basically, it's just trying to get traction, trying to get organized. You see multiple patches of fetch here in the 35 to almost 40 knot range. And then as we get into Saturday, I mean, this is the first run of the model that showed this, but it shows what I call a complex storm with 1, 2, 3 low pressure centers all rotating around each other, all generating fetch in some capacity aimed up towards Fiji and then ultimately to Hawaii, and then east of New Zealand aimed off to the northeast, good at Hawaii and the U.S. West Coast, continuing in some fashion as we get even into Sunday and then starting to fade. Now, is this going to happen? Who knows? Doubt it. But it certainly is a beautiful tease on the models. All right, so what effect are those winds going to have on the ocean surface? That's what matters. Winds getting traction on the ocean surface. So we're going back to today. We have our first pulse of this little system in the southeast Pacific, generating 31-foot seas, and those fade out. Still in the California swell window, regenerating with 28-foot seas aimed at Southern California on Monday. The next system starts forming right behind that with, what do we got? 33-foot seas, 34-foot seas in the California swell window. Again, this is that classic La Nina setup, all from a very south angle, mainly focused on Southern California. Certainly Northern California will get some energy from it. And we're within the 3-day window, so this seems pretty likely, good odds of forming. Then that all tracks off to the northeast and fades out. So that's one. So there is a swell, actually 2 swells in the water right now, 2 pulses of the same swell. Then we get another double pulse system in the southeast Pacific aimed off to the north. And then we start looking, as we get into later next week, into the New Zealand area. A little bit of energy here, likely good for Fiji, up into Hawaii, filtered through the Fiji window. And then these, what is this, 34? Can we do a little bit? Nope, 34-foot seas south of New Zealand, lifting off to the north a week out. Again, a long ways away, but at least it's a tease, and potentially offering some hope for swell beyond that. Maybe summer is finally going to start in earnest. Okay, what's going on with the wind relative to California and Hawaii? Well, we have high pressure, 1028 millibar high off of California, north of Hawaii. You can see Hawaii right there, California there. That'd be San Francisco Bay Area, Point Conception, the San Diego, Mexico border right in there. You get the idea. Trades pushing down the coast to 10 knots, 15 knots, something like that for California. Incessant. The wind has just not stopped for months. This is a continuation. So we've been having this debate too. What is going on with the local California weather? And why is it just the June gloom and the northwest winds and blah, blah, blah? And the short of it is, it's La Nina. And if you look at the water temperature issues or charts when we get to that part of the presentation, you'll see upwelling in cold water is still the norm. Certainly, water is warmer along most of the California coast than it was a couple of months ago, but it still is not quote-unquote normal. It's still colder than normal. Other than this, trades 20 knots, blowing over Hawaii, and that's sort of been a complaint from, everyone sort of chimes in, sends in some local reports from wherever they are. I got a good one from New Zealand earlier today, and a gentleman there was reporting in on conditions and rain and wind and that sort of situation. And the short of it is, all this just smells like La Nina is still in the atmosphere, and summer is not here yet. Irrespective of what, astrologically, I think it was the start of summer was on the 5 days ago in June. We're not there yet. All right, moving out. Monday, northwest winds 15 knots along the California coast and trade still in the 20-knot range relative to Hawaii. Tuesday, pretty much more of the same thing. 15 knots along the California coast, 15-knot east trades into Hawaii. Wednesday, maybe a little bit of a break here along the central California coast early. 10-knot winds, but and more normal, the fetch over Cape Mendocino, 20 knots plus, maybe generating some wind swell. Trades lighten up for the Hawaiian Islands at 15 knots. Thursday, lighter wind regime indeed for California. Lighter trade winds for the Hawaiian Islands at 15 knots. Friday, north winds start building for North California, but otherwise near the coast of Central California, not too bad. Pretty much seasonal, typical. Light trades for the Hawaiian Islands. Saturday, here we go, the gradient, high pressure building once again. 30-knot northwest winds or north winds along the Cape Mendocino coast, generating wind swell radiating down the coast. A little bit, probably not an eddy flow for Central California, but not too bad at the moment. Lighter trades for the Hawaiian Islands with the high pressure being east of them. Then we get into Sunday, 30 to 35-knot northwest winds for Cape Mendocino, but maybe an eddy flow. That'd be south winds along the Central California coast. And then, let's see, we're out of the window there, but basically a continuation of the same. All right, freeze level for the Sierra, specifically along the Pacific Crest Trail, where it intersects with Tioga Pass Road. Certainly no snow or precipitation. Well, there could be precipitation, but not any freezing precipitation forecast. But this is what we're interested in. Where is the freeze level? Okay, this chart depicts the red colors are, maybe I can get it to, here we go. Liquid precipitation above 34.6 degrees is the red. The gray is sleet. Greater than, less than or equal to 34.6 degrees. That's the gray here. The white is 32 degrees or less. So right here is the freezing level. So right now, freezing level at Tioga Pass, and it's at where this intersection is, I think it's about 9,000 feet, 9,200 feet. Freeze level at 12,000 feet. But what you see, boom, come about, the end of the 29th, the freeze level goes up to 14,000 feet and above. This is typically what you'd see when what I call summer starts. You get much warmer temperatures in the Central Valley. The freeze level goes way high. You start getting copious snow melt at higher elevations above. So Mount Whitney is what, 13 or 14, I think it's 14,000 feet, just barely. And this would get snow melt the whole way to the top of Whitney. And I saw some pictures just today of the minarets in that area outside of Mammoth. And there was still loads of snow up high there. And, They're trying to plow Tioga Pass Road. I think they finally got a path through there, but then there's ice issues and there's avalanche issues. So, and we were up at 8,900 feet a couple of weeks ago, and there's still, solid 5 feet of snow minimum everywhere, and higher. It just got deeper and deeper. So, the sense is we've had this steady 12,000 foot elevation freeze level, and it's resulted in good snow melt, but not like some torrential, onslaught of just everything going nuts. Well, somewhere in here is where whatever's left is really going to start melting in earnest. So assuming the model is correct. But the model has been consistently hinting at a major increase in snow level and increase in temperatures. And the start of summer probably is going to be somewhere in this range. So just be forewarned. So what's this all mean in terms of surf? Okay, well, we're going to start up in Northern California. We'll just do Half Moon Bay. These are actual surf heights, forecasted surf heights, irrespective of whether it's southern hemi, wind swell, whatever. You can see 3 to 4 foot surf pretty much consistently through. These are wind speeds here. You see them, 10, it varies day to day. I'm not even going to go there. The swell height. So this is a mixture. You see long period swell starting on Monday and bits and pieces of it. And then there's the wind swell. Okay, how can we, because of the 7, 6, 8 second period. So the wind swell almost kind of buries the southern hemi swell. Swell heights 5 feet, 6 feet. So that's totally burying the southern hemi swell. Maybe we can get a better view of the southern hemi swell in a more protected break somewhere down in Santa Cruz. So here we go. Here's the Santa Cruz chart. You see 2 foot surf building up to 3 feet or something like that on Thursday. What's it all about? Okay, so 1 foot at 16 seconds on Monday, 1.5 feet at 14 to 15 seconds on Tuesday, and then still, look at that, it still gets buried even there, though the reality is somewhere in the middle of all this, there should be a pretty good second pulse of southern hemi swell in the Wednesday, Thursday sort of time frame. Let's go look at Southern California. Dana Point, pretty much totally protected from the wind swell. Small surf sizes in the 1 to 1.5 foot range. Then we get into Wednesday, 3 feet, trickling down from there. That looks like southern hemi swell, and sure enough, you can see it. It's 2 feet at 15 seconds, and then so slowly trickling down from there into the weekend. Now, the real question is, Hawaii, they were forecast to have 2 feet at 15 or 16 seconds, and it ended up being a spike at 3.9, a whole bunch at 3 feet. So it'll be interesting to see whether the swell overperforms in California as it did in Hawaii. We are hoping it did. The GFS model does some weird things with the wave model, and it doesn't seem to be as good as it used to be or as accurate. We're not going to get into the details of why that might be, but clearly there is a sign that it grossly underestimated the surf heights, at least in Hawaii. So Oahu, South Shore, 3 foot surf, slowly trickling down as we get into Wednesday and Thursday, then pretty much out. You can see surf heights, here it is, 2 feet at 14 seconds. When we looked at it just a little bit ago, it was right up at around 3 feet at 14, 15 seconds sort of thing. So add another 50% on whatever that is showing. And slowly trickling down as we get into Wednesday, and then pretty much out, and then it's back to flatness. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and the El Nino Southern Oscillation? These two oscillations are the major predictors of what will happen surf-wise and weather-wise in the Pacific Basin, especially along the West Coast in Hawaii, and especially as we get into fall and winter. So we're going to start by looking for signs of the active phase of the MJO, the Madden-Julian Oscillation. It's this periodic weather oscillation that travels around the planet. 2 phases, active and inactive, and the non-active or inactive phase. The active phase on one side of the planet, inactive phase on the other. They traverse west-east around the equator, one on one side of the planet, the other on the other. The active phase is the one we're interested in. It is a low-pressure system. When it starts pushing over the Pacific, it starts, because it's low pressure, it starts sucking warm, moist air off the ocean surface up high into the atmosphere. That gets caught up into the jet stream. That energizes the jet stream in fall and winter months and makes it more energetic, starts digging out troughs and make it more likely for storm development. The active phase also can dampen trade winds, if not out and out reverse them. Trades normally blow from east to west on the equator in the Pacific. It can reverse them and turn them from west to east. That in turn takes warm water that's normally pulled up in the far west Pacific, driven by the trades, starts pushing it to the east towards Ecuador, but not on the surface. The warm water falls to depths. It follows the thermocline down about 150 meters under the equator. Takes about 3 to 4 months to make it from the West Pacific to the East Pacific. Eventually, that warm water will gurgle up or erupt as it impacts the Galapagos and Ecuador, forming a warm water slick. If you get successive active phases of the MJO, they create and that's known as a Kelvin wave. You get successive Kelvin waves, and that then can start warming water a lot off the Ecuadorian coast. And as it does that, that water starts evaporating, and then that will change the upper level circulation of the atmosphere. And when we talk about the ocean and the atmosphere being coupled, okay, that means the atmosphere senses what's happening in the ocean, starts reacting to it, and then they start reinforcing each other and building, and that is what becomes El Nino. Now, the question is, are we there yet or not? We're going to get into that in a minute. All right, so this is data from the TAO buoy array, a series of buoys strung across the equator. There's the equator right there. That's the East Pacific there. That's the West Pacific there. New Guinea right there. The date line right there. We're just looking at the arrows. Wind speeds. Winds out of the east. You can see, just follow the arrow. The bigger the arrow, the stronger the wind. Strong winds out of the east over the East Pacific. Moderate to strong over the Central Pacific, but much lighter in the West Pacific, right? But it's not the actual wind speed. It's the anomaly, the difference from normal for this time of year. Looking in the East Pacific, we see winds are pretty much normal. I don't see an arrow pointing either east or west. And it's just the east or west component of the wind, not the north or south that matters. Over the Central Pacific, winds are almost out of the west a little bit. And certainly, in the Central Pacific. In the West Pacific, they're almost out of the west too. This smells like perhaps some sort of a weak form of the active phase of the MJO. That's exactly where we want to be. That's the good phase of the MJO. The inactive phase is the opposite of the active phase. It's a high pressure system. It just feeds trade winds, creates upwelling, just stomps on everything. That's where we've been for 3 years with La Nina. Basically, La Nina is a never-ending inactive phase of the MJO. El Nino is the opposite, a never-ending active phase of the MJO. So, some people, I've seen some talks about a couple of years ago, we had great, we had huge surf. We had one day that was probably 50 feet and glassy at Mavericks, back in January, I think it was 2 years ago. That was during La Nina. We still had an active phase of the MJO. It did its magic, but then it stopped. There weren't successive active phases of the MJO. There was one just mega pulse that broke through the La Nina blockade, gave us a bunch of surf for about, I think it was a month, from like mid-December to mid-January, and then it all just shut down, and that was the end of it. This winter, same sort of deal. We were strong in La Nina, but we got multiple pulses of the active phase of the MJO. So we had the coldness of La Nina, but we had the energy from the MJO driving the storm machine. It didn't do much for surf. I mean, the surf was, for the most part, just garbage. But we got the atmospheric river and all the effects of a strong active phase of the MJO producing snow, and that's what gave us all our water, and all of a sudden we're sitting fat, dumb, and happy here with all the reservoirs full. So you don't necessarily need an El Nino, and the active phase of the MJO does not necessarily mean you're in El Nino. You can have them, just like you can have inactive phases during El Nino as well. But typically, during El Nino, it's like a long-running active phase. During La Nina, it's like a long-running inactive phase. Right now, looks like we're neutral, maybe slightly active. Let's go see what the forecast is 2 weeks from now. 850 millibar zonal wind anomalies. What's that mean? Well, 850 millibars is up about 4,700 feet, but that's a pretty good proxy for what's going on down at the ocean surface. And then zonal wind anomalies. Is the wind blowing stronger out of the east or out of the west than normal? The blues are easterly anomalies. Consider that the inactive phase of the MJO. The yellows and reds are westerly anomalies, the active phase of the MJO, the good at MJO. All right, so here we are today. This is the whole plan on one chart, though, so we just got to figure out which part is in the Pacific. Well, dateline for sure, 180 west, that's in the Pacific. Pacific starts about 125 east on the equator, so right there. And the all-important one we call the Kelvin wave generation goes to about 170 west. If you have west anomalies in this box, then you can get a Kelvin wave, and we need successive Kelvin waves to get El Nino. All right, so today in the Kelvin wave generation area, and that's all that really matters, we see, well, the last little bits of westerly anomalies and easterly anomalies starting to build. Now, the model has that happening for about 1, 2, 3, maybe only 3 days, 4 days. Then we go into sort of a neutral pattern, then back to that sort of easterly wind pattern, and then back to neutral. Now, this is the GFS model. Again, I don't trust it, not even a week out, which would be right there, much less 2 weeks out here. Yesterday, when I looked at this model, it showed nothing but westerly anomalies over here after we got past this little couple of days of easterly anomalies. So it's having a very difficult time figuring out what is going on. Let's go look at some other models. This is a statistic model, not the GFS model, just a different type of model showing outgoing long wave radiation. What's that? It's cloud cover, basically, okay? We said the active phase of the MJO is like a low pressure system. Well, low pressure systems generate clouds, so clouds are the blue on this chart. Let's get ourselves oriented. South America there, Central America, Hawaii, New Guinea, dateline right there, equator right there. Kelvin wave generation area right there. This is the area where really that's what kicks off the El Nino thing. So we see yellows today. That's east. That would be cloud-free skies, high pressure, the inactive phase of the MJO. And then going out 5 days, 10 days, 15 days, pretty much a neutral pattern. No sign of the MJO. So we go look at the GFS model. This is a dynamic model, pretty much painting the same picture, but maybe suggesting inactive phase, trying to get a little foothold 2 weeks from now. So not a whole lot different than the GFS model. Let's dig in a little deeper with those two models, the statistic model here, dynamic model here. What are these? These are phase diagrams. Just drills in a little bit more on the MJO thing. So how do you read this? Well, the MJO moves from west to east, from the Indian Ocean to the maritime continent, that'd be like Bali, over the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. So you can see back, where was this? In May, active phase of the MJO moving across the West Pacific. And then as we got into June, it sort of like is meandering around here. And where is it? The heavy dot is where the active phase is today. So in the Indian Ocean, forecast to just be weak and sort of noodling around, so weak to be not even really noticeable. The GFS model, well, here's where the active phase is again, basically suggesting the same thing, a very weak active phase as we get into the peak of summer. And that's really not unexpected. The MJO seems to really do its thing best in like the fall into about February and March sort of thing. And then during the summer months, it tends to kind of be quieter. Next up, the upper level model showing areas favorable for precipitation. The greens favorable for precipitation, we call that the active phase. The yellows and oranges, inactive phase, not favorable for precipitation. 40 days worth of data here, 5 days a panel, 8 panels. South America, Central America, New Guinea, dateline roughly going right there. So Kelvin wave generation area right in here. So it looks like active phase, very weak today, slowly fading out through about mid-July, with then some sort of a weak active phase, but it's not going anywhere, and just basically everything disintegrating into just a neutralness, nothingness, neither active or inactive. Not great for generating Kelvin waves, not great for feeding El Nino, but if the ocean and the atmosphere become coupled, what happens, and if you're all, and they're coupled in a El Nino-ish state, you don't need the active phase of the MJO because you just end up with this steady pattern of westerly anomalies on the date line, and it's just like a long-running active phase of the MJO. And that, in turn, just starts pumping warm water, not like distinct Kelvin waves, but just a river of warm water. Every bit of warm water in here gets pushed along the equator, starts pooling up over here. And that sort of seems like what is trying to happen right now. So then we go to the CFS model going out a month here, okay? Past performance down here, the future here. Notice the black solid line here, or contour. That would be the active phase of the MJO, the dotted line, the inactive phase. Notice that the red wind anomalies, west wind anomalies, and tropical storm formation is best during the active phases of the MJO. This also is when you get your Kelvin waves. So we got one back there in early April. Another one, I think this was number 5 here in April into May. Okay, and then here we are today. It looks like the active phase of the MJO, but there's no black contour around it. And notice that in this model, a little bit of easterly anomalies forecast for, what's that, maybe 3 or 4 days from moving forward, but then westerly anomalies solid, filling the Kelvin wave generation area into the middle part of July, and then we sort of descend into a neutral pattern. So the GFS model and the CFS model have significantly different outlooks on the westerly wind anomaly pattern for the next at least 2 to 3 weeks. So then let's go out. We're going to go out a bit more further in time. We're going to do this a little bit different this time. So this is the outgoing long wave radiation forecast. Cloud cover, the same thing we saw in one of those earlier things. The blues are negative anomalies, more clouds than normal. The yellows, dry air. So this would be the active phase of the MJO. Now, this is past performance here. This is the future. And there's today's date. Kelvin wave generation area starts at 125 east to about 170 west there, and you can take that the whole way up here. So here's the all-important Kelvin wave generation area. Remember, the active phase of the MJO is like a low-pressure system. Low-pressure systems generate clouds. This particular view of the model here, and maybe I can pull it over here for you. Outgoing long-wave radiation is checked. Shows building clouds solid over the Kelvin wave generation area, clearly indicative of the active phase of the MJO. Now today we don't see that. We see a little bit, but this model says pretty much starting tomorrow and every day after that, it looks like a building active phase of the MJO pattern. Now, here's what we're used to. Here's the 850 millibar zonal wind anomalies. It too is showing the yellows, westerly winds building right in the middle of the Kelvin wave generation area, steady as a rock the whole way into September and presumably months beyond that. Let's overlay the MJO thing now. Now here we are. The dotted contour right here suggests inactive phase of the MJO in control at the moment. Yet we still have westerly anomalies. And I think the next 3 to 4 days are going to be kind of really interesting. See if the GFS has it right and we get easterly anomalies, or does the CFS have it right and we're going to get westerly anomalies. The CFS has continually been saying a building westerly wind pattern on the in the Kelvin wave generation area. And you can see here, active phase, active phase, active phase with building westerly anomalies and then a brick wall beyond that. So we'll see if that's how this really plays out or not. Either way, last week, then there was a active phases forecast starting in July 11th, filling the Kelvin wave generation area into the end of September. Not particularly strong, but you see consistent pulses of westerly anomalies. And after that, the MJO, for all practical purposes, just disappears, and we're in a fully coupled state with westerly anomalies and presumably El Nino digging in pretty good as we get into the fall transition time frame, August and September. So this is going to be interesting the next week or two to see whether we do get this westerly anomaly pattern building, or whether easterly anomalies like the GFS model says actually rematerialize. We'll see. It's anyone's guess. What's going on down in the ocean? Okay, we talked about Kelvin waves. Well, can we track them? Yes, we can. We have data from the TAO buoy array. This is the buoy array that was set up after the mega 82-83 El Nino. The scientists realized, God, they were just getting their handle on Kelvin waves and the MJO and all that sort of stuff. We didn't have half the technology we have today. They go, let's go start dropping buoys on the equator. Let's anchor them to the seafloor. Let's put sensors, those Alexas, let's put sensors on those anchor lines. And let's radio beam all that data that we collect from those buoys up to a central processing facility. We use a model to fill in the gaps. And we can literally watch Kelvin waves coming across the Pacific. That'll help tell us if El Nino's coming. Good idea. So we still have that buoy array to this day. Multiple nations across the Pacific contribute to put this and maintain this buoy array. It's no small feat. Anyway, from that we can see 30-degree anomalies, 30-degree centigrade anomalies pushing off to the east. They were 172 or 3 last week. They're moving to 176 or 7 this week, so that's a good sign. The 29-degree isotherm was at 160. Now it's at 157 west, so that's moving off to the east. 26-degree isotherm, pretty much where it was. It was at 120 last week. It's about there. The 24-degree isotherm was about 60 meters deep, and that's where it is too. All this suggests warm water moving off to the east. But then you look at the anomalies, the difference from normal for this time of year. Well, we see warm water at 1 degree above normal with a river. There's a little bit of a break here, and that's a little bit concerning why there's a break there. But we see 3+ degree anomalies from, where is that, 148 west the whole way into Ecuador. I mean, that's a month and a half, 2 months worth of warm water, and 6, almost 7 degrees centigrade. That's what, 11 or 12 degrees Fahrenheit. That's incredibly warm water, and massive amounts of it here slowly upwelling to the surface off of Ecuador. We have another view of that here. Now, this doesn't use the buoys. This is using satellite technology. We'll go look at the source in a minute. It paints a little bit better picture. I was worried about that gap, but we see, well, the cooking 5-degree plus temperature anomalies here off of Ecuador extending the whole way back to, well, it was 138. But this says, here's another Kelvin wave right here organizing, coming into backfill. So this is still probably 3 months from arriving, so we're in the end of June to July, August, September. So we got warm water in the pipe till September, and still more warm water flowing there. This warm water here is 4 months away from reaching Ecuador, so end of June to July, August, September, October. That's a whole El Nino's worth of warm water right there. All we really need, and remember, looking at the MJO model, we're supposed to have westerly anomalies and some pulses of strong ones for the next 2 or 3 months. So yet more warm water, theoretically, if all this comes true, there's enough warm water to get us probably into December, if not longer. So the foundation for El Nino is clearly here. It clearly, in the deep ocean surf, under the ocean, it's El Nino. You gotta say it's El Nino. But the question is about what's going on at the surface. We're not there yet, so let's dig just a hair bit deeper. Sea level anomalies. So this is the source data for the chart we just looked at. What are we looking at? These are not temperatures. Oh, let's get oriented first. Chile, Peru, Ecuador, Central America there, Hawaii right there. That's the date line. That's the equator. There's New Guinea. So what is this? This is sea height. You take the Jason satellite, it orbits polar orbit around the planet. The Earth rotates under that on its axis. I can't twist my hand the right way. And eventually, over a period of about a week, and maybe it's 8 days, something like that, you get complete coverage of the radar beam down on the ocean surface. And it measures the height of the ocean surface. Compared to normal, you strip out the waves, the wind waves, the tides, and is the sphere of the ocean higher or lower than normal? Why does that matter? well, you can infer some things. Warm water at depth, if there is warm water at depth, it expands. It displaces water above it and it'll create a bump on the ocean surface. Cold water at depth contracts, it'll create a divot on the ocean surface. So the blues are negative anomalies. Those would be the dips. The oranges and the reds, oh yeah, you can see the scale down here. These are the positive anomalies. So this suggests warm water. Well, there's Ecuador. There's the Galapagos, 10 centimeter anomalies. Here's that big old ball that we saw that went out to like 140 or 138 or something like that. That's all the warm water. More pockets of warm water suggesting another Kelvin wave there, maybe another one there, and more warm water flowing out from the maritime continent. It's much shallower here. The sun bakes on it, especially if you're in a La Nina kind of mode and it's cloud-free here. And then if you have those active phase of the MJO westerly anomalies, they suck that warm water out of there, start dumping it into the Pacific Ocean. It falls down to depth and then follows a thermocline across, eventually erupting off the Pacific here, off the coast here of Ecuador, and you get your El Nino signal. All right, so what's the trend? Upper ocean heat anomalies. This goes down about 300 meters. It's a little bit generic, but you get the general sense. The West Pacific here, East Pacific here. This goes back a year. Last year, we were in La Nina. Easterly anomalies, strong, high pressure, strong in the Pacific, creating upwelling. Here's all your cold water off of, well, Ecuador's here, just filling the entire Pacific Ocean. And then as we got into like Thanksgiving, a little baby active phase of the MJO kicked off a little Kelvin wave. Didn't make it very far. But then in January, boom, another Kelvin wave. February, another beyond that. Another one in March, another one in April, and the MJO typically takes about 4 weeks to make it across the Pacific, and it was just 1, 2, 3, 4, 5, 6, another one in the May time frame, and you can see all the warm water building up here. Now, we have much less of an intense warm water pool to tap here in the far West Pacific, but that doesn't mean it's over. There's still warm water flowing, just not as intense as it was earlier in the season. So what's going on the ocean surface? Remember, we've been talking about the MJO thing, creating Kelvin waves, and the Kelvin waves traverse the Pacific, but they're all under the ocean surface. It's when they finally start erupting off of Ecuador, here's the Galapagos, here's in Ecuador, you start getting a warm water pool. So let's orient ourselves. Chile, Peru, Ecuador, Central America, Hawaii here, the equator here, or here, depending, this isn't exactly seamed together, but this is the highest res data, the 5-kilometer data. Clearly you see warm water building off of Peru and Ecuador, gets caught by the trades, drag across. This actually looks really good. This looks better than last week. I was a bit worried that, El Nino was stalling. Well, it does a little bit, but this week it's come back looking good. This sort of grayish color now, it used to cut off at 155 west, I think it was last week. Now it's the whole way out to the equator and beyond. The more intense oranges here, they were back at 130. Now they're at 135. They're building. The official El Nino monitoring region is from 120 west to 170 west, 5 degrees north and south of the equator. So a box basically in here. And what we're looking is to watch and see the warm waters start building more out in this area, filling this box. That would raise the index up. The clear good sign here is there's good active Kelvin wave impact activity along Ecuador and the Galapagos. This is not a Modoki El Nino. Let's state the obvious first. This is a clear El Nino signal, right? Sorry, I get a little lost in the details sometimes here. This is a clear El Nino signal, and for this time of year, June, this is a strong El Nino signal. You typically don't see things this mature and this well developed this early in the year. Typically you don't even start seeing this till August sort of time frame. So we're way ahead of the game. All right. Clear El Nino signal, warm water building up to the tip of Baja, down into at least Peru, but not really Chile. And this is the triangle you see here, pretty well defined. Now, what the heck is this? This cold water regime. This is that springtime upwelling La Nina pattern. The June gloom, all this is associated with this. And to me, this is a clear La Nina signal. Wait, how can I have El Nino and La Nina at the same time? Okay, this is the deal. The ocean is not coupled with the atmosphere yet. The ocean is saying, I'm in El Nino, and it's doing its thing. The atmosphere, completely oblivious, driving down the road, I've been in La Nina for 3 years now, and I'm still going. Something strong has to force it to change. I think that's coming. I think we need a little bit more buildup here. I mean, typically I've said it takes 3 months from the time when you start getting this warm water upwelling thing till the time that the atmosphere starts responding. And I'm trying to remember when the warm water thing started. It was like maybe April. So April to May to June to July. And that's why I've been saying like late July is when I think all of a sudden, and with the change of seasons too, that seems to do something to sort of, it'll kick the last lingering bits of La Nina out of the picture. And, okay. So do I want to have that conversation here? I think I won't yet. But this cold signal is part of the La Nina thing it still signals the atmosphere thinks we're in La Nina, even though right next door to it, we have a big old truckload of El Nino evidence going, well, I don't think so. I still think we're in a La Nina pattern locally. Sea surface trend in the past 7 days. Okay, so basically things pretty neutral along Peru and Ecuador. That's not a bad thing. I mean, the water temperatures are about as warm as they can be. I mean, I'd really be surprised to start seeing reds and oranges popping up here. Yeah, we have a little sporadic pockets of cooling. I think that's more attributable mainly to just, local easterly winds, very local sorts of things that happen. But notice from about the point south of California the whole way out to the dateline and beyond, slowly, lightly building warming temperatures. This is exactly what you want to see to start filling out that official El Nino, the Nino 3.4 monitoring region. Again, it goes from 120 west, 5 degrees north and south of the equator, out to 170 west. So we see this part, the western component of the Nino 3.4 region, starting to fill in with warmer water. That's good news. And then again, the backed off view, the clear, obvious El Nino triangle setting up off of Ecuador, Peru, Central America, building some up in this region, and then out to the dateline and even beyond. This area right here is the big change from last week. Building warm waters way out in the Pacific, suggesting that El Nino's grip on the ocean, not on the atmosphere, but on the ocean is expanding. The atmosphere will follow. Sea surface temperatures in the Nino 1.2 area. This is the area right there by the Galapagos and Ecuador. Today's temperatures, pretty warm, 2.455 degrees centigrade above normal. What's that, 4 or 5 degrees Fahrenheit? And basically have been rock solid since somewhere in April. So, good news, no change. And that's no change in a good direction. Now, in the Nino 3.4 region, the official El Nino monitoring region, values today 9.13 degrees, 913 thousandths of a degree above normal. The El Nino threshold is half a degree above normal. So we got a little taste of that in May. It backed off. It was at the end of May. So it was only at the end of May. I was wrong. I said April before. End of May when temperatures finally reached into the El Nino threshold. So if it takes 3 months for the atmosphere to respond after that, so May to June to July to August. August 28th is theoretically when the atmosphere would respond fully. Now that 3 month thing I said, I mean, that's my best guess. It's a rule of thumb. It's not a computer generated thing. I think it'll probably start happening before then. But worst case scenario, end of August. All right, so here's the zoomed in, the June 24th of 2023 sea surface temperature anomalies. Pretty much the same pattern. But how does this compare to the 97 Super El Nino? at this exact same date, June 24th, 97? Well, we see much more intense warming here along Peru and Ecuador, and stronger warming in pockets out to about 155. But if I'm just eyeballing this, nowhere near the breadth or width. So we'll go back. I mean, ignoring the fact that the entire planet's oceans are much, much warmer, what is it, 25, 26 years, from 97. But just looking at this, a definitely more developed El Nino signal, and these anomalies even account for the known warming in the ocean. Okay, so this is supposed to be normal. Okay, so we'll just go back and forth here. 97, and then today. 97, and today. My takeaway on this is the intensity of the warming is not as strong in 97. That said, the breadth and the scale of the warming is much larger than 97. How does that work out in the atmosphere? Well, I guess we're going to find out, but probably they're, at least for right now, in the same ballpark. All right, so what does the atmosphere think is going on? That is the question that we're trying to answer in this video. So we look at the Southern Oscillation Index, difference of pressure between Tahiti and Darwin. Tahiti in the Pacific Ocean, pretty close to the equator. Darwin in the Indian Ocean, and not in the Pacific Ocean. If pressure is lower in Tahiti, the index goes negative. Well, it's positive today at 13.21. We want to see this negative, all right? And so this suggests, at least looking at 1 or 2 days data, the inactive phase of the MJO. But then look at this. Right before that, we had a whole string of negative numbers, a little bit of positive. So this is pretty noisy. So we go look at we take an average over 30 days. And what's it tell us? Well, today's value is minus 6.08. So weekly El Nino-ish. Where were we, though? Looking back, we were down at minus 19.64 there at one point in the early part of June. So this probably suggests we were in the active phase then, going into the inactive phase, or some sort of a neutral sort of thing. And then looking beyond that, the 90-day average, now this is like going back 90 days, or half of 90 days, going back about 45 days. The value minus 7.47, and where were we a month ago? Minus 5.65. So we're slowly getting more negative. The El Nino pattern is slowly trying to materialize, but looking at these numbers, minus 6, minus 7, that's not that far from zero. You really want to see these guys down at minus 20 or 25, and this at minus 15. We're nowhere near that, but considering it's only the end of June, we're very early in the ball game to even be as far along as we are. Let's go look at a graph of this real quick. 30-day moving SOI. The downward spikes are the active phase of the MJO, the upward spikes of the inactive phase. Going back in 21 and 22, we were all in the positive range. There's zero. All this suggests La Nina, La Nina, La Nina, the dominance of the inactive phase over the active phase. And then we hit January 2023. Boom, we just fell off a cliff. Negative, negative, negative. Notice the build back right now. This looks like the inactive phase of the MJO. But we only got in the really negative range somewhere. Well, that's April, May. We'll say somewhere in May. So May to June, July, August. Again, this points to a late July, mid-August sort of time frame for the low pressure El Nino regime, active phase of the MJO dominance thing to sort of start taking a grip on the atmosphere. But what that also means is we have to stay in this negative range. We can't start going positive again. It could just literally, I think there's enough warm water in the pipe, but I mean, theoretically, in the worst case scenario, if all of a sudden the MJO ended up back up here, we could be out of El Nino in a nanosecond. Don't think that's going to happen. There's already too much momentum under the ocean. It just needs to manifest in the atmosphere, and it will. It's just a matter of time. sea surface temperature projections forecast for the Nino 3.4 region, the official El Nino monitoring region. All right, so mid-July is there, mid-June is probably about there. Temperatures in the model, 0.9 degrees, that's exactly where we are. It suggests that we kind of stall and sit here until about July, and then slowly temperatures start creeping up, reaching about 1.65 or 1.7 degrees October, November, something like that, and then starting to fade as we get into January. That would not be a super El Nino. You need to be up at 2 degrees, but this would be a strong El Nino for sure. Anything like 1.5 degrees and above is in strong El Nino category. Now, this is the raw data. The PDF corrected even more moderate than that, saying temperatures about 1.3 degrees above normal. I think this is low. And look at this. It actually suggests temperatures dipping before they start coming back up. So somewhere in the next month, I mean, there is some weird stuff going on with the MJO just being so weak, and the forcing not as strong as it was earlier. Yeah, I can make seasonal excuses for that and a bunch of stuff, but the reality is we just don't know right now. I think the key is the atmosphere has to become coupled with the ocean so they start reinforcing each other, and they are clearly not doing that now. Not saying that that's bad. It's way too early in the season. Maybe this El Nino just started too early and maybe a little bit too early to be good for itself, so it's taking a little bit of a pause. That said, there's so much warm water in the pipe, and there's no sign that really it's going to stop. It's just going to take some time for the atmosphere to catch up, and it's locked. I mean, it's been in a La Nina pattern hard for 3 years now, so we're going to have to see. So in answer to the question, where are we and what's going on with El Nino, La Nina? I think the Pacific Ocean is still in a La Nina state. Why do I say that? Okay, one, the cold water and the continued upwelling and the northwest winds and the June gloom in California. Two, the swell production region. Everything has been focused so much in the Southeast Pacific. We've gotten one swell that's happening right now that's hitting Hawaii, and yes, it's bound for California, but then it's right back to more southeast or very south-angled swells coming into California. Another 2 systems forecast developing right now. Then the one glimmer of hope, not really an El Nino hope, though, is that potential storm developing east of New Zealand. I'll believe it when I see it. It's still a week out on the charts. Now, back to the El Nino discussion. The other component here is high pressure locked over New Zealand. Again, sort of that thing of why are the storms all in the Southeast Pacific? Well, that's because there's high pressure in New Zealand. We've talked to people that are over there. They're saying basically, yeah, it's been miserable. The effects of that high pressure there have been this steady northeasterly flow, and you can see it clear as day on the models. So that's also a sign. Now, here's the other weird thing, okay, and you go, and it might seem like a little bit of a reach, but if you've all been trolling on the internet, you've seen the Skeleton Bay swells, okay? That is another classic sign of energy, and the storm focus being in that, like, off of South Africa, under South Africa, in the Indian Ocean. That's a La Nina thing if there ever was. All the storms are there instead of in the Pacific. So it seems like there's almost a resurgence of a La Nina-ish-like signal in the atmosphere, the last gasp of La Nina in the atmosphere. That said, with all the warm water that's moving, we are going to move to El Nino, but I would say as of right now, I'm not seeing any hard signs of El Nino in the Pacific Basin, or for that matter, anywhere on the planet. The atmosphere is still in a La Nina state. We are waiting for El Nino to develop in earnest. Other than the SOI dropping, that's sort of a sign, but from a weather pattern, show me something concrete that's actually resulting from it. No, not seeing it. It's all abstract signals right now. I think it's coming, but it isn't there yet. Can hardly wait. And with that, we sign off for this evening. Thank you for watching and putting up with this. Be sure and like and subscribe, ring the bell. If you want to donate, that's great too. We appreciate it. And if you have any questions, concern, comment in the video. We'll be sure to try to answer your questions as quick as possible. And with that, have a great week. Go get some surf. Have some fun. There are waves on the way, and make the most of it. All right. See you next week. Same time, same channel. Thanks for watching.